What is inertia? And what are Newton's 3 laws of motion? I'm going to help you understand and make the connection. I've got inertia.
Get off the sofa.
I've got inertia. This car's got inertia. And it's also got the flipping handbrake on. Inertia is an object's reluctance to change what it is doing, what we call its state of motion. If an object is doing nothing, its inertia is the thing that means a force must be applied for it to do something. If an object is moving, then its inertia will keep it moving at the same speed in the same direction until a force acts on it. My inertia in a braking car keeps me moving forward. That's why it is so important to wear a seatbelt. Forces are needed to oppose inertia. This is what Newton's first law is all about. A body will continue at rest or at a constant speed in a straight line until a resultant force acts to change this state of motion. Take this ball. If I throw it in outer space, it will travel at the same speed and in the same direction forever until a resultant force acts on it. Put simply, Newton said that when a body is left alone, it maintains a constant velocity. This is a clever and rather profound statement. It tells us that there is nothing special about being at rest. After all, what do we mean by not moving? Most of the time, we're only talking about our motion relative to the surface of the Earth, which is itself rotating at around 1,000 miles per hour around its own axis. The Earth is then orbiting around the Sun, which is then part of our spinning galaxy, which itself is moving in our local cluster of galaxies, and so on and so on. So what really is stationary? Newton's second law describes how an unbalanced force changes the motion of a mass. In its full form, it states that the resultant force acting on the mass is equal to the rate of change of momentum of the mass. With momentum being equal to mass times velocity, we can write Newton's second law as resultant force equals mass times acceleration. The same force applied to two objects, one with a small mass and one with a big mass, will produce a lot less acceleration with the big mass. Newton's third law tells us that forces act in pairs. For every force that acts, there is an equal force that acts in the opposite direction. Imagine a cannon firing a cannonball. The cannon exerts a lot of force on the cannonball and it experiences a lot of acceleration and flies off towards its target. The cannonball exerts the same force on the cannon, but in the opposite direction. Because the cannon has a lot more mass than the cannonball, it does not accelerate as much, but it is still noticeable. This is called recoil. Now here is a problem for you to solve. Imagine it's the middle of a very cold winter spell and you've got your thick coat on and you are stuck in the middle of a frozen lake. On this imaginary lake there is no friction at all and so no way for you to walk or push off the ice. How can you get to the edge of the lake? I'll leave the answer to this problem at the bottom of the description somewhere below, down there. While you're clicking around, if it's not too much trouble, like the video and subscribe to the channel to encourage me to make more. Guess what? Over here is another video you may like and enjoy.